we are gonna sit down and do this assignment. So we do the odd problems and I'll point out different reasonings for the even problems here. So we have this big string of multiplication. The big thing is that I can write this actually in any order. Remember, multiplication can go in any other order. So I'm gonna put my coefficients first. So 2 times 4. These are just coefficients. Those are not exponents. Make sure you remember that. So it's still just 2 times 4. Now let's use a different color here. We're gonna go ahead and write down the n squared. And that's all the n's I have. And let's go ahead and we'll write down the m's. So we'll have m squared, m to the third, and an m. If there's no exponent on a variable, there is a silent 1 there, and that might help us remember to add them. So in the end, what we're gonna do is we're gonna end up multiplying the 2 and the 4, so that's 8. These ones, by definition, if I have n times n, because that's 2 n's, right? We're gonna go ahead and call this n to the third, or we can just shortcut and add their exponents. Same thing here, 2 plus 3 plus 1, so that'd be 5 plus 1, which is 6. We're gonna say that, right? So I rearranged it. You don't have to show all that. You can kind of just visually say, all right, in this problem, I'm gonna multiply 2 times 4. I'm gonna add the exponents for the x's, so I'm gonna do 4 plus 3, so that'd be x to the 7th, and this guy doesn't have anything, so we just leave it alone. We have even more on this problem here. We're gonna take the 2 times the 4, which is 8. We're gonna have to add some exponents of several things, like the x to the third is 1, 2, there we go. So we'd end up getting x to the third to the 4th, and then we add 2 more to the 6th. So far what we have is 8 x to the 6th. And then I add up my y to the 3rd. That gives me y to the 5th. And then I add 3 more, y to the 8th. So I'll let you try that. These problems, again, multiply, add their exponents. Nothing on this one. Over here, we have x to the 4th to the 9th. We could longhand look at that, like to the 9th power means rewriting it 9 times. That's a crazy amount of times. But then what we'd end up doing, let me count that I have this. 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have 9 x to the 4ths. Well, that's repeated. We'd have to add them all up. But remember, repeated addition, as we've talked about, is multiplication. So a shorter way would be 4 times 9, which is 36. That would be much easier than having to write out all this. We just multiply. So here you do the same thing. Multiply 4 times 2. This one would be easier to think out though, right? Like here we'd be like, oh, there we go. Done. What about this one? This gives us y to the negative 12th when I multiply. Well, if I look at the directions, it says only positive exponents. That's not positive. We have to remember our property that says if we have a negative exponent, we do 1 over the positive version. So we'll do that same thing on number 8. Multiply these. It's going to give you a negative, right? Do 1 over that negative exponent. Down over here. Now, there is a property, but I'm going to show out in case you missed it. Again, this is the same as 2r squared times 2r squared times 2r squared. And I did 3 of them because it was to the 3rd power. And it's saying everything in the parentheses to the 3rd power. So all of this times itself 1, 2, 3 times. And so that gets going to get me, well, I have 3 2's here. Another way to write that, 2 to the 3rd. 3r squareds here. This is r squared to the 3rd because it's times itself 3 times, which gives me 8r to the 6th. I could have either just multiplied those or added the exponents, or the shortcut is to do the 3rd power times both into both of these. So it'd be 2 to the 3rd and r squared to the 3rd. A common mistake might be getting your multiplication messed up with exponents and being like 3 times 2. But again, the 2 is not an exponent. The 2 is a regular coefficient. It has an exponent of 1 that's silent there. So don't be careful about that. So to get you started on this one, you would do 4 to the 4th, which means 4 times 4 times 4 times 4. I think I said that 4 times. And r to the 3rd to the 4th, which you'll use your previous property up there that says if you have an exponent raised to an exponent, you multiply those two exponents. I'll do one more like that for you right here. Like this one, 3 to the 3rd, n to the negative 12th, because I multiplied those. So this is going to give me 27 times 1 over n to the 12th. But that looks kind of messy. Remember, I can kind of squish this together since I'm multiplying these. Call this 27 over n to the 12th. Lastly, we got the last ones have a bunch of fractions in it. I'm going to separate and think of these separately. You don't have to write them separate, but I'm going to for here. So I'm treating this like its own fraction. Try not to put properties of exponents to these coefficients though. This is just going to become 1/2. So I'm simplifying that like a regular fraction. In this one, there's a property that says we subtract their exponent. So I could do 3 minus 8, or I could think of it like this, x, 1, 2, 3, 4, 5, 6, 7, 8. And the fact that each set, did I get 8 there? I did get 8 there. Each set's going to cancel out. And so what I end up having, nothing on top, so this is x to the 5th. I could have also done a subtraction rule there. Or I could say, hey, there's an x to the 5th left on bottom. All right, so that would have been one way to do that. I'll show you what I mean with the subtraction though. So we already showed that 4 over 8 is 1/2. If I did 3 minus 7, I would get r to the negative 4th. Well, that becomes 1 over 2 times 1 over r to the 4th. And so it just gets left over on bottom. So apply that idea here and here. 3, 10, that doesn't simplify to anything. Neither does 4 and 7, so don't beat yourself up about that. This u doesn't have anything that's going to cancel out with. 7 over 7 is just 1, so we can kind of just go boop. So we end up having u v squared over v cubed. Again, use that subtraction principle, so this one will simplify to u over v to the 1. I like to just think of like, well, what's the difference? There's one difference between them. And where is there more? There's more on bottom, so I'm going to leave the leftovers on bottom. Same thing here. The 8's cancel out. Again, the y's aren't canceling out because there's several y's here. It's like y squared, y is y to the 10th. Oh man, why did I choose to write this out like this? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Got it done. So like they are canceling out, but only some of them, right? So now I have 8 left over here. Nothing on top, so we call that a 1. And so we'd say 1 over y to the 8th. We could have also just subtracted that and would have been y to the negative, 10, y to the negative 8.